Good evening. Today I will be discussing deductive versus inductive forms of reasoning. The reason we're about to go into this lesson is simply because the unit that you will be working on during the first part of these first 9 weeks is logic. And logic is about critical thinking that allows your mind to expand and you start to be creative. So we're going to start with deductive versus inductive reasoning. Your project, like I said, will be a crime mystery game, and you're going to have to use deductive and inductive reasoning to find out who your suspect is or who the culprit is. And she has pencil and paper so you can take notes as well. Two basic categories of human reasoning. Deduction. Deduction is reasoning from general premises which are known or presumed to be known to more specific, certain conclusions. Induction. Reasoning from specific cases to more general but uncertain conclusions. The key word there is certain for deduction, uncertain for induction. Both deductive and inductive arguments occur frequently and naturally. Both forms of reasoning can be equally compelling and persuasive, and neither form is preferred over the other. Deduction versus induction. Deduction, commonly associated with formal logic, involves reasoning from known premises or premises presumed to be true to a certain conclusion. The conclusions reached are certain, inevitable, and inescapable. So in other words, when you're doing deductive reasoning, you're going to have solid evidence, something that can be proven, not something you think or your opinion, but something that you can prove for certain. Induction, commonly known as informal logic or everyday argument, like you argue with your friends about what TV show is the best or what actor is better than the other actor. That's everyday argument. You cannot prove those things. It involves drawing uncertain inferences based on probabilistic reasoning. The conclusions reached are probable, reasonable, plausible, and believable. However, it is not certain. Deduction. It is the form or structure of a deductive argument that determines its validity. The fundamental property of a valid deductive argument is that if the premises are true, then the conclusion necessarily follows. The conclusion is said to be entailed in or contained in the premises. Example, use of DNA testing to establish paternity. Paternity means establishing who's your father or who your child's father is. Induction. By contrast, the form or structure of an inductive argument has little to do with its perceived believability or credibility, apart from making the argument seem more clear or more well organized. The receiver, or a third party, determines the worth of an inductive argument. And you'll be able to find what premises mean. Is this inductive or deductive reasoning? And we'll start with this one right here. A sample of 50 motorists who were stopped by the CHP at the sobriety checkpoint on Saturday at midnight revealed that 1 in 4 drivers were either uninsured, intoxicated, or both. Thus, if you get involved in an accident on the freeway, there's a 25% chance the other motorists will be drunk or uninsured. next one right here. The law of the sea treaty states that any vessel beyond a 12-mile limit is in international waters. The treaty also states that any vessel in international waters cannot be legally stopped or boarded. Therefore, when the U.S. Coast Guard intercepts boats coming from Cuba or Haiti more than 12 miles from the U.S. coast, it is violating the law of the sea. What did you come up? What did you say this one right here was? Deductive or inductive? Write your answer down. And what do you say this one right here is? Deductive or inductive, and why? When you're looking back at the premises here, it states that 1 in 4 drivers are either uninsured, intoxicated, or both. You cannot generalize this information right here, simply because just because 1 in 4 people stop at a checkpoint and you have a sample of 50 motorists, just because they were stopped at a checkpoint does not mean that anybody that you could get involved in an accident is going to be a 25% chance that the person be drunk or uninsured. This information and this data does not accurately line up with this data. Now, this data about the treaty, it completely lines up with this data at the bottom. So, this would be inductive reasoning. This would be deductive reasoning. Example of deduction. Major premise. All tortoises are vegetarians. Minor premise. Bessie is a tortoise. Conclusion. Therefore, Bessie is a vegetarian. Example of induction. Boss to employee. Bill has a tattoo of an anchor on his arm. He probably served in the Navy. Just because Bill has a tattoo of an anchor does not mean he served in the Navy. You cannot prove that unless he tells you that. But you can't just look at a tattoo and say, oh, he served in the Navy. Sample Venn diagram of a deductive argument. When you're making a Venn diagram of a deductive argument, you draw your circles, such as this right here, and all your circles overlap, as you can see. Okay, so you put your first set of premises in one circle, and you put your second set of premises in the other circle. Okay? A vegetarian animal. Tortoises are vegetarian animals. All tortoises fall in a circle of animals that are vegetarian. Thus, Bessie must be a vegetarian if she's a tortoise. And we'll talk more in class about how to do Venn diagrams as well. Other types of deductive arguments. Suppose every place in the world that people live is represented by the blue space inside the rectangle. Suppose the long pink oval represents all the wooden houses in the world. And suppose the green circle represents Canada. The most logical conclusion one can draw from the figure is A. All wooden houses are found in Canada. B. Everyone lives in a wooden house. C. Some Canadians live in wooden houses. D. No one lives in Canada. What would your answer be for that one? Let's go over it. Every place in the world that people live is represented by the blue space. And this is the blue space. The long pink oval, which is here, represents all the wooden houses in the world. And the green circle, which I don't see, the green circle, is Canada. So, automatically you can go ahead and X out Canada. Because I don't see a green circle in there. I see the state, so I don't see the 3 states. Let me skip this one because I don't think that one came out correct too right. I don't see my 3 states. So X this one out. We'll go to the next one. I'm sorry, I didn't know that slide was missing. Go to the next argument. I'm sorry. Okay. Suppose the following statements are true. Person L is shorter than person X. Person Y is shorter than person L. Person M is shorter than person Y. What additional piece of information would be required to conclude that person Y is shorter than person J? What additional piece of information would be required to conclude that person Y is shorter than person J? So the solution is answer C. M is shorter than Y. I had that right there, so you already put that right there. Person M is shorter than Y. That's what this represents. Y is shorter than L. L is shorter than X. Okay, so if J is taller than L, Y must be shorter than J. So what information do you need? C. You would need to know that person J is taller than L. You understand that? If you don't, please write yourself some family that go through it when you return to class. Alright. A mother wants to order one large pizza with exactly 5 toppings for her 3 picky children. She can choose from 7 toppings: cheese, mushroom, olive, ham, sausage, onions, and pineapple. Fifi says there has to be pineapple. Mona says there cannot be any olives. Rex says that there is going to be sausage, then there has to be ham too. Which combination of toppings should she select if she is to satisfy all 3 children's combined demands? Okay. We know there has to be pineapple. Okay, so that's number 1. You have to have pineapple. Which means everything and the answer selection right here that doesn't have pineapple in it, you need to go ahead and cross that out. Mama says there cannot be any olives, which means now you can go back over here and cross out everything that has olives. So right now we've crossed out D, and we've crossed out B. Correct? Okay. And Mr. Rex says that if there is going to be sausage, then there has to be ham too. The only choices we have now is either A, with pineapple, onion, cheese, mushroom, and sausage, and B and C, with cheese, mushrooms, ham, onions, and pineapple. Okay, so Rex wants sausage, basically, because he said there's going to be ham. He said there's going to be sausage, there has to be ham. But he did not say there's going to be ham, there has to be sausage. Okay. So A could not be the proper choice because he has sausage here but no ham. So your choice would have to be C. Why? Because it has everything that all the 3 children want, and it doesn't have anything that they don't want. Deductive reasoning is either valid or invalid. A deductive argument cannot be sort of valid. It has to be either valid or invalid. If the reasoning employed in the argument is valid and the argument's premises are true, then the argument is said to be sound. Valid reasoning plus true premises equals a sound argument. Inductive reasoning enjoys a wide range of probability. It can be plausible, possible, reasonable, credible, and etc. The inferences drawn may be placed on a continuum ranging from cogent, which is right here, and fallacious, right here, or fallacious, at the other end. Deductive reasoning is commonly found in the natural sciences or hard sciences, less so in everyday arguments. Occasionally, everyday arguments do involve deductive reasoning. Inductive reasoning is found in the courtroom, the boardroom, the classroom, and throughout the media. Most, but not all, everyday arguments are based on induction. Alright, so that's the end of our slideshow. If you need to go back and do any practice, make sure you can do the practice and do your handouts on Jupyter, which I've included as an attachment on Jupyter. And you have a wonderful spring break, and I will see you when you return.